Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizul Ilmi bin Hasan. So I'm from Group 7. So today I will present to you about the Project 1 question. So this is our group member. The first one is Muhammad Atahari bin Azizan. Second one is Muhammad Fazil bin Zulkarnain. The third one Ahmad Kushairi bin Viseli. The fourth one is Muhammad Aiman bin Johari, and lastly me is Muhammad Faizul Ilmi bin Hasan. So next is introduction. So we our group need to do a question project 1 which involve chapter transportation problem and project management chapter. So for the introduction, I will explain a little bit of the definition, which is the transportation problem deals with the distribution of goods from several points of supply to a number of points of demand. Usually, we have a given capacity of goods at each source and given requirement for the goods to each destination. So next, the critical path of a network gives the shortest time in which the whole project can be complete. It is the chain of activities with the longest duration. There may be more than one critical path in a network, and it is possible for the critical path to run through the dummy.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Kushairi bin Visli. Today I'm presenting about question 1, which is the transportation problem given. Above can be represented in the following transportation below, which is like this one. In this question, they ask for initial basic feasible solution by northwest corner method, and then we need to find an optimal solution. So both supply and demand, if we total out, we get 700. Like the supply, we need to add up, like 100 plus 300 plus 300, we get 700. While demand, 300 plus 200 plus 200, we got 700 also. So both supply and demand, if we total out, we got the same answer, which means that which means that this transportation problem is balanced. Okay, so next slide. This is how the northwest method would be done. In the northwest method, northwest corner method, which is the largest possible allocation is made to the cell in the upper left hand corner of the W, followed by allocation to the adjacent of feasible cells. So in this case, the northwest corner would be in the A1, which is 100. Sorry, which is $5. So we put $100 because we only have the supply A, we have only 100. So we can only provide demand 1, which is 300 divided by 100, divided 300 subtract with 100, we get 200. So there is 200 demand left on the on the demand 1. So the supply needed is 100, so we put it on A1. There is demand left on the there is a demand left, which is 200, demand 1. So we put it on B1, 200. So how much can it supply? It can supply, yes, 200. So 300 subtract with 200, we get 100 for the supply, for the B supply. And then there is no demand left on the demand 1, so we cancel the C1. Next we go to the for the supply, there is no supply left on the supply A, so both A2 and A3 will be cancelled out. And next will be B2. Okay, what happened to the B2? Okay, B2, uh, the demand needed is 200. So how much can it supply? Is 100. So for the B2, we get 100. So supply on the supply B will be nothing left on the supply B. So we go next to the B3. Because of there is no supply left on the B, we cancel out the B3. So we go to the C2. There is a demand left on the on the demand 2, which is 100. So we put 100 on the C2. So the supply on the B will be the supply on the C will be 300 divided with 100. So we got 200 on the supply C. For the okay, so there is no demand on the demand 2. So we're moving on the demand 3. Demand 3 is 200. So the cell that we need to occupy will be C3. So just because we need only 200, so there is only 200 left on the supply C. So we just put 200 on the C3, and the total will be 700, both supply and demand. Okay, the total cost would be 100 multiplied with 5 plus 200 multiplied with 8 plus 100 multiplied with 4 plus 100 multiplied with 7 and plus 200 multiplied by 5. We got $4,200. So that's for Northwest method, but we need to find the Northwest we need to find an optimal solutions. So we're moving on to the optimal solution, which is Modi method. Next slide. For the Modi method, we have this table is come from the Northwest corner method, which we put it here in the Modi method, and then in the Modi method we need to calculate between occupied cell and the empty cell. This empty cell and the occupied cell have its own formula, which occupied cell is Ui plus Vj equal to Cij. So for the V1, we need to find the V1 value. UA is always 0 or always equal to 0. So in this formula, UA plus V1 equals to 5. We need to substitute the UA value, which is 0, equals 0 plus V1 equals to 5. And then equals to 5. And then for the UB plus V1 equals to 8. For the UB plus 5, this 5 is come from the substitution of V1. So the formula would be UB plus 5 equals to 8, and then UB equals to 3, because 5 transfer into the right hand side. So 8 subtract with 5, we got 3. And then next we need to find V2. UB plus V2 equals to 4. So UB, substitute the UB value, we got 3 plus V with V2 equals to 4. So 3 transfer into the right hand side. So the formula would be V2 equals to 4 subtract with 3 equals to 1. So V2 equals to 1. Next will be UC plus V2 equals to 7. The one that we need to find is UC. So UC plus 1. 1 is come from the substitution of V2. So UC plus 1 equals to 7. 1 need to be transferred into the right hand side. So 7 subtract with 1, we got 6. UC equals to 6. Next is we need to find V3. UC is 6, so we need to substitute in this formula. So 6 plus V3 equals to 5. And then 6 transfer into the right hand side. 5 subtract with 6. Subtract with 6, and then we got V3 equals to negative 1. Okay, for the emptied cell, which is Cij, subtract with Vi and subtract with Vj. Okay, for this empty cell, there is 4 empty cell in this table. So the first table would be the first cell would be SA2. SA2 equals to 4 subtract with 0 subtract with 1 equals to 3. That's for SA2 equals to 3. And then SA3 equals to 3. Subtract with 0, and then we subtract with negative 1, we got 4. And then for the SB3 equals to 3, subtract with 3, and then we subtract with negative 1, we got 1. And then the last one, the last cell, is SC1. SC1 equal to 9, subtract with 6, and then we subtract with 5, equals to negative 2. So there is 2 negative value in this MODI method. So we need to find another optimal solution, which is stepping stone method that will be presented by my group mates, which is Muhammad Atari. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Athari. I will continue present about question 1, which is optimal solution using stepping stone method. The stepping stone method will help us move from an initial feasible solution to an optimal solution. It is used to evaluate the cost effectiveness of shipping goods via transportation routes not currently in the solution. So each MODI allocation replicate the stepping stone allocation. After each allocation to an empty cell, the UI and VJ values must be recomputed. So the first table show that how the stepping stone work, and the second table is result after using the stepping stone method. So the total cost after stepping stone method is $4,000, which is optimal solution because the value is more lower than minimum cell cost, which is $4,200. Then we need to recomputing UI and VJ values. So as you can see at the slide, occupied cell UI plus VJ equal to Cij. So we get the V1 is 5, UB is 3, V2 is 1, UC 4, and V3 is 1. After we recomputed the UI and VJ value, we must calculate cost changes for the empty cell, which is Cij minus ui minus vj. So as you can see at the slide, A2 we get 3, A3 we get 2, B3 we get minus 1, and last but not least C2 we get 2. After we calculate the cost changes for the empty cell, we can conclude that since have the values of negative, solution obtained is not optimal. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Aiman Menjuari. Today, I want to explain the answer about project management such as critical path method and early start, early finish, and late start and late finish. These two very interesting tools in the world of project management. So, imagine a big job with a lot of tasks that all need to be done at the same time. How can we make sure we finish one time? A critical path method can help with that. So we can see the question. We need to find the critical path for each activity network. The critical path is the set of the tasks that take the most time to take complete. Delay in this job have a direct effect on the whole project schedule. It's like the project backbone. If it cracks, the whole thing could fall apart. So the answer from for the critical part is the first one is A to G equal 6 plus 2. The answer is 8. Second is B to D to G equal 2 plus 4 plus 2. The answer is 8. The third is B to D to H equal 2 plus 4 plus 3. The answer is 9. Fourth is a B to H to E to H equal 2 plus 5 plus 3. The answer is 10. Fourth is a C to E to H equal 4 plus 5 plus 3. The answer is 12. And lastly is C to F equal 4 plus 7. The answer is 11. For the second answer, for activity early start, early finish, late start, late finish. For activity A, time is 6 and early start is 0 and the early finish is 6, late start is 4 and the late finish is 10. So the activity B, time is 2, ES is 0, EF is 2, LS is 2, LF is 4. For activity C, the time is 4, early start is 0, early finish is 4, late start is 0, late finish is 4. We goes to the activity D, the time is 4, early start is 2, early finish is 6, late start is 5, late finish is 9. For the activity E, the time is 5, for the early start is 4, early finish is 9, late start is 4, late finish is 9. Activity F, the time is 7, early start is 4, early finish is 11, late start is 5, late finish is 12. Goes to the G. For the activity G, the time is 2, early start is 8, early finish is 8, sorry, early start is 6, early finish is 8, late start is 10, and the late finish is 12. And the lastly activity is H, the time is 3, early start is 9, early finish is 12, late start is 9, late finish is 12, and go to finish. And then that's all from me. Thank you.
Okay, thank you, my friend. Okay, my name is Muhammad Fazil bin Zulkarnain. ID number is 5721212141. Okay, next, my part is question 3. Okay, this question is: an oil company has two depots, A and B, with a capacity of 7,000 L and 4,000 L respectively. The company is to supply oil three petrol pump D, E, and F, whose requirement are 4,500 L and 3,000 L and 3,500 L respectively. The distance between the depot and petrol pump is given in the following this table. If the transportation cost of 10 liter of oil is 1 per kilometer, how should the delivery by schedule? In order the transportation cost is minimum, what is the minimum cost? Okay, the answer is: to minimize the transportation cost, we need to find the shorter path from the depot A and B. So, the petrol pump D, E, and F will consider the capacity constraint the depot. We can research the problem using a transportation table. This is a table for the D, E, and F. Okay, next we start by filing the cell with the smallest possible value where respecting the capacity constraint. We can start by filing in the cell corresponded to depot A, like this table. And now we are moving to depot B. We can only supply oil to petrol pump F since the oil from depot A. So already supply the minimum distance to pump D and E, like this table. Okay, so the total transportation cost is like this: 405 kilometer, 7 kilometer plus 305 kilometer. This is 3 kilometer, 3,100 and 1,015. So this answer is 4,200. Therefore, the minimum transportation cost is 4,200. So this note is the concept of ES, EF, LS, and LF used in critical path method for project schedule, which is not applicable in this problem. Okay, thank you. That's all for me.
For the conclusion, this presentation has shown way to solve each given question. Each question was solved with its own path. So I hope from the presentation, the audience can easily understand how to solve the problem which involve the transportation problem and also critical path from the project management chapter. That's all from our group. Thank you.